The best way to learn anything is by doing something you love. So today I'm going to teach you some basic physics concepts by playing one of my favorite video games, Fortnite. Alright, hello everybody. My name is Fletcher and I'm an aerospace engineer by training and a gamer by night. And my goal is to teach gamers like you subjects such as physics, science, engineering, economics, finance, even adulting, simply by playing all of our favorite video games. In this three-part video series, we will be learning my favorite physics subject, kinematics, the mathematical description of motion without regard to causes. This is just a fancy way of saying we will learn 4 basic projectile motion equations that can be used to calculate how a grenade shot out of a launcher will fly. So let's start simply by shooting a grenade straight up in the sky and seeing what we can learn. Now, this is as straight up and down as I can make it, but it will be good enough for now. And the first step in any physics problem is figuring out what we know and what we can learn. So let's pause it right at the peak of its flight. So as we saw, he shot it from the ground all the way up to its peak. So we're going to start on the ground where d, distance, equals 0. We're assuming where he shot it from is 0. Time, that's when our clock starts, that's 0 as well. Velocity coming out at the instant it's shot, we don't know. We're trying to find that out. Now let's look at the peak. At the top, distance is, well, we don't know that yet. And that's also what we're going to find out from this kinematic equations. Time, well, we timed that, we cheated a little bit. That's 1.6 seconds if you time the video from when it's shot to its peak. And velocity at the peak is 0. Now that's a little counterintuitive, but it makes sense. So if you think about it, at the very top of its peak, right before it hits it, it's traveling upwards, right? And then it comes back down, it travels downwards. And so right before its peak, it's going up, right after it's going down. So there's an instant in time where it's sitting perfectly still with 0 velocity. The last thing we know is that gravity is a force pushing down on the grenade as it's traveling upwards. And in any physics textbook, you can find out that gravity is 9.81 meters per second squared because it's an acceleration. In truth, there's probably one more force acting on it, which is air resistance, but also like any good textbook, we're going to ignore that to simplify this problem. We can now use the kinematic equations to solve for velocity at the ground and distance at the peak. And we're going to use 2 of them to do this. We're going to start with the first one, which is velocity at the peak equals velocity from the start plus acceleration times time. So time at the end. And we know these things, and what we're trying to solve for is velocity at the ground. So let's rearrange this using simple algebra to solve for v0. So we move and subtract acceleration times time from both sides, and we end up with velocity at the peak minus acceleration times time equals velocity at the ground. So we know, now let's put numbers to the equation. Velocity at the ground equals 0, which is the velocity at the peak is 0, minus acceleration. Now acceleration is actually a negative acceleration because it's acting in the opposite direction to the path of travel. So it's actually 0 minus negative 9.81 meters per second squared times time, which is 1.6 seconds. Equate that out and you get velocity at the ground is 15.7, and now let's use our units, meters per second, because the second squared and the second cancel out. So now let's write that 15.7 meters per second down at the bottom where we initially wrote out velocity at the ground. Next, we're going to solve for the distance at the peak, d1. So d1 equals velocity at the ground plus velocity at the peak divided by 2, which is the average velocity of its flight. Multiply that by the time of its travel. The second kinematic equation, like all the others, only work under the assumption of a constant acceleration. And in this case, gravity is a constant acceleration, so this works very well. Okay, so let's solve for this. equals velocity 0, which we know now to be 15.7 meters per second from our previous equation, plus velocity at the peak, which is 0, divided by 2, times time, which we measured previously at 1.6 seconds. Punch this into a calculator, and you end up getting 12.56 meters. And that is the distance that the grenade travels upwards at its peak of travel. And there you have it. We used kinematic equations of projectile motion to calculate the velocity of the ground and the distance that a grenade traveled upwards. And so I hope this was a good example of how we can play some video games and learn at the same time. And there you have it. Thank you all so much for watching my first video of 3 where we're learning about kinematic equations of projectile motion. Now in the next 2 videos, we will learn the remaining 2 equations we didn't go over this time. We will still be using Fortnite Grenade Launcher examples, just slightly modified. And this will be a good way of showing how we can learn at the same time as we're playing some of our favorite games. So thank you all so much again for watching it. If you liked it, please subscribe, and I'll see you next time. Goodbye!